keep its length the same, just simple dragging. And I'll take another example. Later on, we'll see another example. Vector S, then if this is vector A and this is vector B, this is A, this is B, S is the vector from the beginning to the end. This is S, okay? طيب, الآن, let me show you, I have other examples and properties of the vectors. Some of the properties of the vectors is that arrangement in addition is not important. So if we say A plus B is similar to say B plus A, let's see why. Let's take this example. Here, this is A and this is B. If you add them, means you start from the beginning to the end. This green one is A plus B. But also, assume you start with B. طبعا هذا الB, I drag it as it is here. Assume you start with B, means you start here with B instead of A. So B plus A, طبعا what I did for A, I just did drag it from here. I drag it. So did I change anything? No, A here is the same A here. I did not change anything. It's the same angle of inclination and it's the same length. So I did not change anything. Whether you say A plus B or you say B plus A, you get the same thing. So A plus B, you get this A plus B, this green one. Or B plus A, notice that you get the same one, B plus A or A plus B. You get the same vector, this green vector, to indicate whether you say A plus B or B plus A. This property of vectors, in adding them, arrangement is not important, is called commutative. Commutative means the arrangement, the order when you add the vectors is not important. Whether you say A plus B plus C is the same as say B plus C plus A, is the same. You should get the same vector summation of all of them. You should get the same vector. The blue is the distance, the blue is the length of the vector. The blue is the length of the vector. The head is the direction, the direction, inclination, ميلانه عن الX axis. Okay, I hope everybody has understand my English very well. So the angle of the vector is its inclination with the X axis. This is the direction. So this is 45, this is 55, this is 90 relative to the X axis, which means it makes 90 degrees. That's the angle of the vector. If I want to add this vector that's 90, I just need to drag it without incline it, without change its slope or orientation. Fine. So this is the first property, which is called commutative. Let me see the chat. Can we subtract? Yes, we will come to this, inshallah. We'll come to this. Fine. We have another property called vector addition is associative. What does it mean, associative? It means if I add vectors like A and B and C, I can either say to start A plus B, then C, or I can say A plus B plus C. Yani, I can add first those two vectors and then add C, or I add B and C and then add to them A, I get the same thing. Let's prove it. If you take here, this is vector A, وهذا vector B, وهذا C. Okay, now notice, what is A plus B is C is this vector. Yeah, it's correct. This is A plus B plus C. But you still can get A plus B plus C if you do the following. What if you first added A plus B, then C, you get the same one, A plus B plus C. Another way, what if you first add B plus C, which is this one, then you add A, where is A? Where is A? This A, so A plus B plus C, what you get? A. يعني in all the situations, you got the same vector, A plus B plus C. So arrangement and associating two vectors and then add them to a third vector in addition is okay. I can first say A plus B, then add C, or say A added to two vectors B plus C together. That's the property called associative. Then what happens if I say I have a vector B and what is minus B? Minus B is the same vector only reversed by 180 degrees. So if this is vector B, means pointing up 90 degrees, minus B is the same vector flipped 180 degrees. So here, for example, I have vector, let's take this, I have vector B, vector B. What is minus B is totally the inverse of vector B. So what happens if I want, what happened if I want to add the vectors b plus minus b. وش أعمل؟ b plus minus b. Here I have the b. On the head of b, I add the minus b. So I went back to the same point. Means the addition should be 0. So this is how I add vectors. So you should know the negative of the vector is reversed by 180 degrees vector, but it has the same length. This is why I can express a subtraction a minus b as a plus l minus b. As if I add to vector a another vector, but this time it's not b, it's the minus of the b, because it's the same as saying a minus b. So here I have a and I have b. So what is a minus b? This one. So I just subtract this. So as if I say a and هذا minus b. So where is that vector? This is d اللي هو a minus b. Clear? I hope it's clear. طبعا this, of course, this assumed to be knowledge you know before, but as I told you and I promised you at the beginning of the course, I take you as if you know nothing. As if you know nothing. Let me just quickly see the chat panel. Yes, 0, perfect. A minus b is 0. Or b minus b is 0, not 2b. Okay, then I have to correct this. Type, good. Good. Now let's take this first checkpoint. Okay, let's take this first checkpoint. The magnitude of displacements A and B are 3 and 4 meters. So I have two vectors. I have vector A and I have vector B. Vector A is 3 meters and vector B is 4 meters. يعني more lengthy. Okay? He did not tell you anything about the directions of A and B. They can be like this, they can be like this, they can be any direction. So he did not tell you any information about their direction. He just told you the magnitude of vector A is 3 meters and the magnitude of vector B is 4 meters. Okay, good. Now he's telling you another information. He said vector C is the addition or summation of A plus B. So if I add the two vectors A and B, I get another vector called C. That's another information. Considering various orientations of A and B, if you consider any possible orientation of A and B, what are the maximum possible magnitude of C? يعني if I try to add A and plus B, when I will get the addition to be the maximum? If I do this angle, this angle, this angle, this angle, or imagine this. What if I align the two vectors like this? I get the maximum. لأنه what's the summation of A plus B in this case? From here to the end. صح? كده. When you put the two vectors like this, head, tail, head, this length is the maximum C, right? Let me see the chat panel. I hope you guys agree with me. Yeah. To add them in the same direction, to add them in the same direction, you get the maximum value of the vector C. So the answer should be 7. The maximum possible magnitude of C is 7. And when this happens, when I align A and B in the same direction, either this way or this way, or this way or this way, it doesn't matter. He said, what is the maximum possible value of the magnitude of C? He did not say about the direction of C. He said, what's the maximum possible value of the magnitude of the vector C? So it should be 7. Should be. Length cannot be negative. That's why we say it's a magnitude. Length of the vector there is no meaning of its being negative. Length is the length. قطعة. بتقيس طولها. It has nothing to do with direction. Okay? It's not position, it's length. طيب. Now part B, what is the minimum possible magnitude? So what is the orientation to get the minimal value of A plus B? So we said if A plus B this way is the maximum, what if I subtract them? What if I align them like this? I'll get another vector, maybe 5 في الوتر, huh? 3 and 4. What is the hypotenuse of 3 and 4 according to Pythagoras law? Will be 5. So it cannot be small. But I can achieve smaller than 5. What is smaller than 5? If I subtract the two vectors. If one vector pointing, for example, to the right, the other one pointing to the left, or one of them is up, the other one down, then the subtraction, one of them is opposite to the other. So if I want to add A plus B, I need to drag this to the beginning. A difference between them is this piece, which is 1. So a difference between two vectors, when they are totally opposite, is the minimum value I can get. Is the minimum value I can get. A opposes to B. So the minimum magnitude is 1. Okay? Remember, the magnitude, absolute value, length only. Okay? No, it cannot be negative. The magnitude has to be always positive. The magnitude has to be always positive. Type. Now, we have a vector. Each vector has something called components. And just to remind you, maybe in high school or in prep year, they taught you it's called murakkibat. The components of a vector, each vector consists maybe, if it's along the xy coordinate, Cartesian coordinate, then this vector might have a component along the x and might have a component along the y. Let's take this color. So if I have this vector b, هذا الفيكتور حرسمه b, the projections of the vector along the x وال projections of the vector along the y, these pieces, هذه البيس is its y component and this piece is its x component. Now notice the components, please write it down if you wish. The components of a vector are scalar quantities. Because it's important, very important. Components of the vector are a scalar quantity. Yeah, it's okay, it's fine. كيف? I can write the vector B as having two components. One along the x, I will call it bx I hat. طبعا الفيكتور يجي من الاي هات هذه. اوكي؟ بلس by j hat. What I'm telling you is that شوف هذه الكومبوننت، اختار another color. See this component؟ هذه bx و this component by. هذه only are scalar. وتذكر قواعد السكيلر. Scalar value can be positive, can be 0, can be negative. A scalar that can be 0, positive, negative, we said another important characteristic before, and I asked you to write it down. A negative means it's small. A negative of a scalar quantity means it's small. Where 0 is bigger than the negative. That's important. So this vector B has two components, bx and by. If I know the orientation of the vector, I can predict the two components. كيف؟ هذا الآن حنرسم فيكتور أبسط منهم. هذا فيكتور A. هذا فيكتور A. وهذا الفيكتور A, say its length is 3 units. 1, 2, 3 meters, right? 3 meters. Now say that this angle is 50 degrees. طبعا هذه الانجل relative للpositive x, right? Now if I complete this triangle, complete the triangle here, this component is the ax, where this component اللي هي this one, or طبعا same one is here, is called ay. The component ax, if you notice, because it's along the positive x, is positive. Well, component ay is also positive. Can you give me what's the value of this scalar quantity called the component of the vector A? The quantity of ax is what? According to the rules, remember, of chapter 1, the first lecture I taught you, trigonometry, I said this is important, we need it later. We said we can know ax by saying it's the length of A, اللي هي hypotenuse, cosine 50. كيف عرفت أنا cosine 50? What is this? This is adjacent, right? المجاور. هذا القطعة من المثلث, I was describing it according to the cosine. Why? Because it is the adjacent. هذا الهايبوتنس. يعني أنت كيف تعرف الكوساين؟ Again, وش الكوساين؟ الكوساين adjacent divided by hypotenuse. المجاور على الوتر. Right? So what is the adjacent? ax divided by a, cosine 50. Correct. Can you give me now what can be the definition of ay, this piece? Yeah. Remember, we defined the sine, the angle, as the opposite divided by hypotenuse. So, let's see the chat. Yes, a sine 50. Why? Because it is the opposite. Where opposite to which angle? To this angle. ممتاز. المعجل raised hand. Okay, let me see. في سؤال? Anybody wants to ask question? عبد العزيز? Anybody wants to ask question now? Good. طيب ما في سؤال. طيب خلينا نعمل some modification so that we make sure I make sure that you guys understand it. Say that you have vector A here. Same one. وهنا الانجل كم؟ 50. هذا الانجل كم؟ 50. What are the components؟ هذه AX وهذه AY. بس say أنا أبغاك تكتب another way to write the components. أبغاك تكتب هذه الكومبوننت وهذه maybe you don't know هذه 50. If you don't know this angle and I give you this angle 30, can you still write the components؟ أنا ما أعطيك هذه ال 50 هذه raised it أعطيتك اللي هو sorry the rest of the 90 is 40 هذا أعطيناك هذه 40. Now what is this؟ اكتب على الشات what is this؟ الكومبوننت هذا السايد no yeah no what's this؟ لا هذه مش AX هذه along الY but what's its value؟ صح cosine ال 40 right? If this is 50 and this is 40, this here, this side of the angle, because it's the adjacent to this, should be what? A cosine ال 40. So here it is called A. طبعا أنا بحط absolute value to indicate magnitude. Cosine مين؟ ال 40. واحد راح يقول wait a second. الكوساين هنا والكوساين هنا. The cosine here is different than the cosine here. The cosine here because it's adjacent, but still I will have to call this as what? A sub y. I have to call it A sub y because it's along the y-axis. Now, هذا الضلع, what is it? اكتب على الشات, what do you think this should be? يا سلام. A sine ال 40, and it is AX. Now you guys understand. طب حنعطي مثال آخر. أنا أبغى على الشات, I want it to be interactive. We will call this vector C. ساعدوني هذا الفيكتور C. And now this angle is 30. اكتب on the chat CX. CX means which one is CX هذه complete the triangle. This is what? This is CX. الكومبوننت C cosine 30 but في catch. Is it negative or positive? It's along a negative y, a negative x, sorry. So it has to be negative C cosine 30. And how about this اللي هي ال y axis or y component اللي هي C y, this piece? Is it positive or negative? It's positive. How much is it? It is C sine 30 and it should be positive. إذن the component of the C came to be negative ال x وother one y. حنعطي كمان مثال. معلش حنعطي كمان مثال. شوف حاخذ هذا الفيكتور D وهذه الانجل ثيتا. يلا اعطيني الدي اكس. وين الدي اكس؟ هذه ايش تعريفها؟ بوزيتيف اور نيجاتيف؟ هذه القطعه along البوزيتيف اكس بوزيتيف. What is it? D cosine 30 or theta, sorry. Why? Because this is the triangle. And how about this piece اللي هي ال y? It should be negative. And what is defined as? Minus D sine 30 or theta, sorry, I keep saying 30. Minus D sine theta. If you know these four examples, trust me, you need them in Physics 101 and Physics 102 to understand vectors. طيب. We continue. Now these two components, we know that we can define them as I show you, either a cosine or sine, depends on their location along the x or the y. But another thing, if I have a sine with cosine, like this example here, هذا ال A, هذا vector A, and this is theta, So this is what? This is A cosine theta, this is A sin theta. Can you know length of the vector A اللي هو length هذا? Yeah. The length or magnitude of the vector A is, according to Pythagoras, is the square root of ax square component plus ay square component. This is Pythagoras law. يعني if you know the components a, x, and ay, can you know a? Yeah, because according to Pythagoras law, a is the magnitude absolute value under the square of ax square plus ay square. Another thing, what if you don't know the angle and you know ax and you know ay and you don't know the angle theta? Tell me the angle. Well, I can know the angle if I know the lengths of the triangle, some sides, 2 sides out of 3, I can find the angle. So tan theta is what? Opposite divided by adjacent. What is the definition of the tan? Tan, we said it's of opposite divided by adjacent. So it is ay divided by ax. And if I know the length ay and I know the length ax, I can find the angle. طبعا tan theta. Then how to get to theta? You said I take the inverse. So theta inverse is equal, or sorry, theta is tan inverse على calculator of ay over ax. This is how you find the inverse on the calculator. Type. We need this information. So let's take this first example. We took examples before, but they're like checkpoints. A small airplane leaves an airport. Let me check just here a pencil. Let me see a chat first. If anybody has a concern on the chat. This is good. Tan inverse. Yeah, arctan. Arctan. Some books they call it arctan. Some books they call it tan inverse. This is good. This is good. Type. A small airplane leaves an airport on an overcast day and later sighted 215 kilometers away. So this is an airplane. And it leaves an airport, had a tower of the airport, and sometime it's located 215 with an angle 22 degrees relative to positive y, or طبعا it will be what? 68 relative to positive x. Same thing. Either يعني انت the way you describe the airplane, you said والله the airplane location relative to the y or relative to the x is up to you. Okay, both of them is correct. Whether you said relative 22 degrees here or 68 degrees here is the same direction, right? It's the same orientation. It is the same orientation. Yes, thank you. The same. طيب. In a direction making an angle 22 degrees east of due north. كيف يعني east of due north؟ هذا due north. هذا النورث. East of north شرق الشمال ب 22 درجة بالعربي. شرق الشمال ب 22 درجة 22 degrees toward the east relative to the north. So 22 degrees east of due north. How far east and north is the airplane? يعني tell me x component وtell me y component. هذه السكيلر quantities of this location of the airplane. أول حاجة x component لك الخيار. يا إما تقول هذه x component and I take it from sine 22. Why sine 22? لأنها الopposite. Or you know this angle 68 and you said لا أنا أبغاها من cosine 68. إذا ال A اللي هي dx, two things. Either you say it is d, شوف هكتبها هنا, two solutions are the same. Cosine 68, which is equal to saying it d sine 22. If you put on the calculator, by the way, عشان أنت ما تتلخبط, cosine 68 on the calculator is equal to the sine 22. متممة 90, the angle, the two angles that they complete each other to the 90 degrees, they are equal. Cosine is sine, opposite, not cosine, cosine, cosine and sine. So for example, sine 30 is equal to cosine 60. Cosine 30 is equal to sine 60. So those two, cosine with sine, they complete each other. They're equal. Okay, they're equal. Now, find a dy. What's a dy? يلا together. A dy component, either I say, a dy اللي هي هذه, either I say it is d, أول solution, d cosine at 22. صح, لأنه هذا. or it is, I can say, relative to this angle اللي هي 68 اللي هي what? D sin المثيل chat. الجميع يجاوب D sin 68. Yes, D sin 68. In both cases, you get the same answer. I give you the two possible answers. Both of them are equal. Either you describe it in terms of the sine, or you describe it according to the cosine. Let me see. Anybody has a question so far? Good. Taz. So once we know the components, we said, remember, النوت اللي أبغى أكررها كثير. The components of a scalar quantity, components of a vector are scalars. Scalars means they're just numbers. They can be negative, they can be zero, they can be positive. When negative for the scalar, we said it should be small. طيب. Here, unit vector are vectors, small vectors, so we call them unit vectors. These unit vectors are either called I hat or j hat or called k hat. These unit vectors, they share the same property. All of them, they have the same length, which is 1 unit. 1. So magnitude is say like 1 meter or 1 centimeter. So in terms of magnitude, الطول, those 3 unit vectors are of magnitude 1. Another property, I hat always points along the x-axis. J hat always points along the y-axis. Well, k hat, by the way, this is k hat اللي هو coming out of the page. اللي هو points along the z-axis. By the way, z-axis, شوف ركز معايا. هذا الx, هذا الy, coming out of the page is the z-axis, the third axis dimension. Okay? So this is the z-axis. So it has a unit vector called k hat. So if I want to describe a vector along the xy coordinates, it's simple. I say vector A is axi hat plus ayj hat. Now, if I know the components of the A, those scalar quantities, خلاص, I can know a vector A because I can describe his components. If I know the value of the component, I can describe the vector. خليني أعطيك مثال. What if you want vector A? Draw for me vector A that is 5i hat minus 2j hat. نيجي هنا نرسم Cartesian coordinate. Sorry, here. كم نقول he has 5 units along the x, 5i hat, 1, 2, 3, 4. They should be equal, huh? Mind my drawing. And 2 components along the j hat. إذا هذا الفيكتور اللي هو A. هتقول كيف عرفت هذا A؟ لأنه it has 5 components, 5 positive values. هذه شو positive ها؟ along I hat و 2 negative along j hat. So this is vector A. هناخذ مثال آخر. أرسم C which is minus 3i hat minus 2j hat. ارسم لي هذا الفيكتور. So we do this. Vector C يقول minus 3i hat. Okay. 1, 2, 3 هنا. وminus 2j hat 1, 2. طبعا بإمكانك أنت تعمل حاجة زي كده. So C. هذا الفيكتور C. Now this vector C has 3 units along the negative x and has 2 units along the negative y. Now I can write any vector, صح? Any vector, if I give you the components, you'll be able to draw for me any vector, right? By the way, تقدر تعرف length? Yeah, if I know the components, square root, square, square. So simple. You know the angle? Yeah, tan the angle. So I have information about the vector. Let's take some examples. The quantity axi hat and ayj hat are vector components. Yeah, by the way, here ركز معي حاجة مهمة. هذه وش قلنا عنهم هذول؟ between الدوائر هذه وهذه. اكتب what I said about them. الcomponents. Are they scalar or vector? Write on the chat. Are they scalar or vector? Scalar. ممتاز. Scalar quantity. أرقام. Right. Good. Now, listen to this. Here, how about all this? هذا vector. How about all this? هذا vector. أول ما طلعت vector كون ورطنا. Why? لانه قلنا from dimensional analysis of if the left side is a vector, each term of the right side has to be a vector from dimensional analysis. What is the thing that gave it this characteristic to be a vector, اللي هو I hat and the j hat? The existence of the I hat attached to the scalar made it a vector by itself. The existence of the j hat made it a vector. Made it a vector. Excellent, excellent, excellent. Okay. Now, we learned a way to add vectors by saying we add vectors if we know, just 1 second. We know the vectors, we add them. If we add them graphically, we can know the summation of the vector. But also, if I add the components, I can know the summation of the vector. كيف? If I have vector A and I have vector B and I want the summation RA plus B. So what do you think Rx will be? I add the X component to the X component. Well, Ry, I add the Y component of the B to the Y component of the A. And the RZ component is the AZ plus BZ. So if adding, you have two ways to add a vector. Either graphically, بالرسم, or you add the components, but you cannot add the AX للBY. You can add the AX to the BX. You can add the AY to the BY, and so on. You can add vectors of the same components. Let me see. طيب خليكم معي. Okay, I'm here. We still have 5 minutes. Okay, just 1 second. طيب. So we said, let me share. I think I stopped the sharing. Where's here? Zoom. Share screen. Yeah, share. Okay. So we said we add the vectors. We add the vectors by adding their components, right? طيب. What happens if I multiply a vector by a constant? I have vector A and I multiply it by the number 3. What I get? 3 times the A. So if I multiply a vector by a constant, I have vector A multiplied by 3. This is A. If I multiply by 3, I did not change anything. What happens if you multiply it by minus 3A? What you get? Minus 3A, صار هذا. And so on and so on. What happens if I multiply it by half an A? It becomes half, but the same direction. يلا half A. Where is half A? هذا half A. Right? What about minus half A? هذا minus half A. Opposite, but half that length. Then multiplying a vector by a number, by scalar or a number, means I can know, its length or change its direction. Change its length or change its direction. Okay. طيب, let's take this example and we'll finish with it according to adding vectors by their components. طيب, let's focus with me, please. We have vector A, 4.2 meter. طبعا you need unit, its length. So you need the meter length unit. 4.2 meter I hat minus 1.5 j hat. Or vector B minus 1.6 I hat or 2.9 j hat. Or vector C minus 3.7 j hat. Now, how to draw these vectors? A, احنا قلنا كم؟ A has 4.2. شوف 4.2. And minus 1.5, yeah, 1 minus 1.5. I managed to draw vector A. I just give you the components. You managed to draw vector A. Draw vector B. Minus 1.6 صح على X and 2.9 على Y. Yeah, شوف here. And vector C, where is vector C? Only has a J component, doesn't have X. So it is here. So you have, طبعا, how much is it? 3.7, negative J hat, right? طيب. Now, if I want to add the vectors together, what should I do? R, find the vector R. First, I add the X to their X. The X to their X, I have AX or BX or CX. AX is 4.2, well, BX minus 1.6, well, CX is 0. CX doesn't have X, you see, it's 0. It doesn't have I hat. I add them 2.6. طب add الآن ال RY, find the component لل R اللي هو RY, AY, BY, CY, you add them minus 2.3. Where is this vector اللي هو مكون من 2.6 شوف هنا و minus 2.3. يا سلام, this is the vector R. You managed to draw it. هذا الفيكتور, if you try to do the vectors by graphically, you should get this vector اللي هو ال R. If you try to find the vectors graphically بالرسم انك ترتب, and we will do it maybe now if we have time, then you will get the same vector R. Actually, I will do it. Then find the magnitude of R, the length of R. What should I do? هذا الفيكتور R. Now this is Rx, and this is what? Ry. What is the magnitude of R? Square root تربيع الأول, square is the second one, 3.5. So the length of this vector R is what? Length, 3.5 meters. And what is the angle of vector R? Here you have two choices. Either you tell me all this angle, you said relative to the positive x, which is 300 something, or you tell me this angle وهذه بتكون negative, لأنه if you select the angle in the clockwise direction, it should be negative. طيب, إحنا we select to make life easy, هذه small angle. I know it's negative, but can I find its magnitude? Yeah. Theta tan inverse opposite divided by adjacent. What's opposite? 2.3. Adjacent 2.6. So it's minus 41. طيب, الآن I owe you something. We need to do it graphically. هذا الفيكتور A, let's add them. هذا الفيكتور B اسحبه زي ما هو عند ال A. شوف كيف أنا طبعا roughly I'll make it. بسم الله. يكفي. Notice what I did. I just dragged this here. هذا B. Now I need C. Where is the C? هذا C. Now I will drag it. شوف كيف عمل؟ زي ما هو. Yes, salam. Look how beautiful. Look how beautiful math is. Now what happened here is that when I added A plus B plus C, what I got vector R. So graphically you got the same results, and even by doing the components you got the same results. طيب, any question يا شباب? طيب, let me see the chat. يا سلام, tan theta. طيب يا شباب, so that we be on time, we stop inshallah. We meet you on Thursday. السلام عليكم.